Today's lab, what's inside the Earth? Do you think the Earth is made up of a bunch of rocks? You might have to think again. From what you've learned in our chapter on gravity, you've known the mass of the Earth and the radius of the Earth. You can calculate the average density. Now you're going to go outside and find some rocks. You're going to have to measure their density. Getting the mass of the rocks is easy. You've got an electronic balance. We're talking small rocks. Well, how about their volume? You can get a small plastic cup, cut out a small notch at the top, put in a small straw, but just a little section of it. You'll need some tape. I even used a little Vaseline to try to seal it up. Fill the cup all the way to the top with water. The water is going to start to drip out. Let it settle down to an equilibrium level and don't touch it. Now, can you imagine lowering carefully the rock into the water? You don't want to cause a big splash. That water is going to spill out. Now, you could capture it in a graduated cylinder, which you don't have. So you get your electronic scale, put a small empty cup on it, tear the scale so it's zeroed. Now, when you carefully lower that rock into the water is going to dribble out and go into the cup. Now you put the cup on the scale and you weigh it. Let's say it reads 7.35 grams. That's 7.35 cubic centimeters, because that's from the density of water. What else is on the surface of the Earth? How about water? Like 2/3 of the surface is covered in water. So you want to estimate the average surface density of the rocks and the water altogether for the surface of the Earth. Compare that density to the average density of the whole Earth. You're going to see a difference. Then you can think about what's inside the Earth. I went outside, I got myself a couple of rocks, washed them up, and dried them. Now I'm going to weigh them. I got 59.11 grams. How do I get the volume? Well, you might think I could put them in this big pitcher and capture the water that spills out. We're going to fill this with water until it starts to drain out. I'm going to just let it sit now. Stop dripping. Since we don't have a graduated cylinder, I'm going to have to weigh the water. So I'm going to take a cup, put it on the scale, and tare it. Now it's zeroed. I'm going to capture the water. I'm going to carefully put the rock in. And now the next rock. Now I can weigh the water. I get 21.21 grams. That's the same as cubic centimeters. Now we actually have one of these volume by displacement cups that we buy from the science company for our use in lab, but you can make your own. I just took the straw, stuck it in the side with tape, put a little Vaseline in there to seal it up. Again, I'm going to fill this up until the water starts to pour out. I've got the cup tared. Now I carefully put the stones in. And now I'm going to weigh it. I get 22.2 grams. You actually get a little bit better of a result with the small cup because the water level rises more. It's narrow. This doesn't rise as much, and surface tension can hold back the water. So I get a density of about 2.7 grams per cubic centimeter for the stones. So water has a density of 1 gram per cubic centimeter. Maybe we should check out the density of some steel. That's made mostly of iron. I've got the cup tared on the scale. I get a mass of 101.56 grams for the 2 nuts. I tear the cup on the scale. I'm lowering the nut gently into the water so it doesn't splash because it'll drop in there. And the next one.
Oh, yeah.
I get a mass of 13.63 grams, which is the cubic centimeters. Well, I get 7.5 grams per cubic centimeter for the steel. Could that give you an idea about what's inside the Earth?